Good morning, students. So today we are going to discuss the topic with very interesting activities. So now you see the activities and then you tell which topic we are going to discuss and what concepts. Okay. So now the first, I'm just showing this thing. You are thinking, ma'am, what is doing? Okay, just to see how much air the balloon has blown up. What you observed? As the amount of gas I was blowing from my mouth, the balloon was more and more inflated. The balloon was more and more expanded. So this is what? Means the gas, the air which we blown from the mouth and the volume is increases. Let's see one activity, how the amount of gas increase the volume, and then after we'll discuss it is which concept. And now see, as the gas is released out, the balloon is again inflated, the inflation is it's become flattened. Now the second, carry forward the second activity. You can see these are the three beakers. Okay, you can see over here. In this beaker, what I have taken? Acetic acid, right? So I have taken the same amount of acetic acid, and in this balloon taken sodium bicarbonate. So now see what happens when this sodium bicarbonate mixed with this acetic acid. Let's see first. Okay, you can see the reaction is going on as the sodium bicarbonate reacting with acetic acid, the balloon is inflated. Why? Because some gas is coming out. Because when sodium bicarbonate reacts with acetic acid, there is a formation of CO2 gas. So inside the carbon dioxide gas is coming. So this gas helping inflated the balloon. Okay. Now see the next beaker. Next conical flask. Same procedure. Add slowly. Okay. Now observe it. Same reaction is going on. CO2 gas is released out. But what you are observing, is the balloon size similar? No. This balloon is more expanding, more inflated. It means it's showing that the amount of CO2 gas is more in this case rather than this. Now see the third one. Again do the same experiment. And now observe it. What will happen? Slowly we have to add. And now see what observation we will get it. Now see what is happening. The balloon is more and more inflated because the more amount of CO2 gas released out. I have taken the same amount of acetic acid, but the sodium bicarbonate 1 gram, 2 grams and 3 grams. So more reaction occur and more CO2 gas released out. As the amount of gas increases, the size of the balloon also increases, or we can say the volume is increases. You tell me it is which law? Right, it is which law? ABC laws. In which, so today we are going to discuss ABC laws. What is the meaning of A? Avogadro's law. B. Boyle's law. C. Charles' law. So these are the laws of gas laws. So this activity which you have shown, the inflated balloon by blowing the mouth, as the air was more and more, the volume was increases. Here also, as the gas of CO2 is more and more, the balloon sizes increases, or we can say the volume increases. So this is called Avogadro's law. And what you are observing, all these are occurring at the same temperature, that is at room temperature and at the same atmospheric pressure. So what two parameters of gas parameters are changing? volume and the amount of gas by keeping temperature and pressure constant. So what is Avogadro's law? Volume is directly proportional to the amount of gas at constant temperature and pressure. I hope it is clear. Okay. Now move to the second activity. Now the second activity is just there is a two bowl in which I have taken cold water and other I am going to take the hot water. Now see and what happens, then after you observe and let me see what will happen. So this is the warm water, boiled water, you can see. Okay. Now these two balloons, okay, almost the size, similar, slight difference, but almost similar. Okay. In this case, what constant? The amount of gas is constant, means what are the amount of gas inside, that is constant, and the pressure is constant. Only the two factors will be changes. We are changing the temperature, and when we change the temperature, see how the size of the balloon will vary. Okay, so now I am keeping these two balloons in this two. This is a cold water and this is a warm water. Okay, so just leave for the some time. If we'll keep in the boiled water, if it will be boiling, will be continue, you will see the balloon will expand and expand, maybe burst also. And when if the water is cold or ice cold water for the long time, you see the balloon size start shrinking and it will be shrink. So now I am leaving for some time so that the process will continue, and then again we'll come to this activity and we see the observation. Now moving to the third activity, and second activity is pending. So now moving to the third activity. This is what? Syringe. Okay. The volume of syringe is 50 ml. Okay. So I have just taken this balloon, the small size. There is a very inflation is very less. Okay. So now this inflated balloon I am just putting in this syringe. You can see. Okay. Now this is at the minimum pressure. Okay, so there is no pressure. Now close this so that the volume will the amount of gas remain constant and temperature constant. Now we are changing the pressure. Okay, so now this is at the low pressure. See what happens if we increase the pressure. So when we increase the pressure by closing the mouth of this syringe, you can observe it. The balloon is shrinking. Okay, now when I am moving it, okay, so this is like this. But okay, you can see the balloon has been shrinked, flattened. Now when the pressure increases, now moving outside, pressure decreases, sorry. So when pressure decreases, you can see the balloon is inflated. The size of the balloon is increases. Better you can see once again. Okay. Just I am again doing the same activity. As the pressure increases here, when we increase the pressure, the balloon of the size is what? It's shrink, it's flattened. But when decrease the pressure, you can see the balloon size increases. Okay, just again I am showing. If the pressure decreases, you can observe over here the balloon size is what? Increases. So what happens? The pressure increases, the size decreases, and the pressure decreases, the size increases. So this is what? So what you are observing? The volume is inversely proportional to the pressure. So it is which law? It is Boyle's law. So Boyle's law states that the volume is inversely proportional to the pressure at constant temperature and constant amount of gas. I hope it is clear. Now I was doing the activity, that is heating activity. Now you see, let's see what observation we have. Okay, now observe it. What happens? The size of the balloon what? Increases. It's not very much increases, but slightly increases. If you keep for a long time, the balloon will more and more expand. The volume will increases. And in this case, there is a slight decrease the size of the balloon. Okay. So what you are observing, at high temperature, in boiled water, the balloon expanded. Means at high temperature, the volume is increases. The volume is more. At low temperature, means in cold water, the volume decreases. So what we are observing, the volume is directly proportional to the temperature. Temperature increases, volume increases. Temperature decreases, volume decreases. So it is which law? It is Charles' law. So Charles' law states that the volume is directly proportional to the temperature at constant pressure and amount of gas. Already I told the pressure is constant and the amount of gas inside is also constant. Only the change of temperature and volume. Clear? So we have just seen A, B, C laws. That is, V is directly proportional to T, V is inversely proportional to P, V is directly proportional to amount of gas, N. So when we combine all A, B, C laws, what we'll get it? V is directly proportional to N by T upon P, or we can say PV is equal to nRT, which is called ideal gas equation, where R is a gas constant, which is a constant value, and what value has to be taken? It depends on unit. Now, so we can write PV by NT is equal to R. Okay, R is a constant, gas constant. So if we take 2 or 3 or different temperature, pressure and amount of gas, so what we can write? P1 V1 upon N1 T1 is equal to P2 V2 upon N2 T2. Suppose we are taking the same amount of gas and same gas, if the N1 is equal to N2 for the same gas, for the same amount of gas, so what we observe? P1 V1 upon T1 is equal to P2 V2 upon T2, and this is called gas equation. Clear? I hope you have liked this activity. So we have done 3 activities. One is the A law, that is Avogadro's law. B law, that is Boyle's law. C law, that is Charles' law. All these activities can be easily done at home even also, because vinegar which I have taken inside, that is nothing but that is what? This vinegar that is we use at home even also. And the sodium bicarbonate, that is nothing but this is a baking soda which is also available at home. So we can do all these activities even at home under the observation, supervision. So thank you so much.